Hello. All right, so I hope you guys are doing well, hanging in there, and continuing with your material whenever you can. So at this point in physics, we're moving on to graphing. We're going to be going through a couple types of graphs, but for this lesson, we're going to be focusing on uniform motion graphs, which means graphs that actually aren't involving acceleration and it's just traveling at a steady speed. This first video is going to be focusing on distance time graphs. And then we'll be working into position time graphs, and that will be that. It's also going to be really important that you know how to calculate slope and understand that the meaning of this value actually changes depending on the type of graph you're looking at. All right, so first off, starting with uniform motion. When we were talking about speed and velocity, we discussed there can be kind of average speed, instantaneous speed, and uniform. Now, the definition of uniform motion is motion that would be in a straight line and at a constant speed and velocity without any acceleration, deceleration, or change in direction. Now, one example of this would be using the cruise control function on a vehicle. Sets the speed, maintains it, and you stay traveling in the same direction. Now, really, we've kind of mentioned this before, very little natural motion is ever really uniform. But for this section, for simplicity's sake, we're going to be kind of graphing, often using just averages in order to demonstrate and see what uniform motion looks like. Okay? All right, with graphing. Now, graphing hopefully is not new to you, and it is part of many math and science topics. So hopefully these are kind of familiar things. Now with physics, or anything really, you have an x and you have a y-axis. So if I were to just draw myself a little graph here, the y-axis is the vertical axis and the x-axis is the horizontal. Okay, very important for that to be, familiar to you. Now for us, often time is a variable with physics. Time is going to be often the variable that is on the x-axis, which leaves the other variable on the y, which might be speed, it might be distance, might be displacement. Now, it's very important that when you are creating your own graph, not just necessarily interpreting it, that you create a scale that is even and represents the data appropriately. So if you are drawing a graph on a piece of paper, your graph should take up as much space as possible. And this is in your control in terms of creating the scale. So what I mean by that, if you kind of just follow up here, let's say those were my lines of paper, and let's pretend that they are even. Now I can't really set a scale that would be, 0, 3, 5, 10, 12. Let's pretend those were my data points, but I can't just use my data points as my scale. When I'm creating that scale, I have to evenly space out my lines. So maybe I would choose to go up by 2 and then graph my data points accordingly. So let's say my data point was 7. Well, I would know it would go in between those two. So many people make the mistake of using the data as the scale, but that is just not the case, right? You're in control of creating that scale. It needs to be even. And the y and the x-axis don't have to be the same. So I could choose, even though my y-axis went up by 2, maybe my x-axis goes up by 1. Okay, so if I were to correct you and say, your scale is not even, that would be what I'm referring to. All right, now there's going to be an assignment in your workbook. It's page 13. I'm going to ask that you complete that graph and submit it as an assignment submission. Now, it's going to be really important that you follow appropriate graphing rules. So first off, when you're graphing, you should always need to kind of set your graph up. So even before you look at any of the data, you need to have a title and you need to label your axes with units. So instead of just saying time, I need to say time and in seconds or minutes or whatever it is. So you label your x and y axis. Time is typically going to be on the x-axis. You make sure that your scale is evenly spaced. You start plotting your points with a small dot. And then often when you're done, you need to draw a curve or line of best fit. Now with a line of best fit, it's very important that your line matches your data, but it actually does not have to connect the dots, right? A line of best fit is like a trend line, which is typically using a ruler to just kind of show the general pattern. So let me just do a quick sketch here. Let's say these were my data points. Okay, now a line of best fit is not about a connect the dot, all right? It's about taking a look at this data and creating a trend line, which in this case would actually just be a straight diagonal line essentially through the middle of the data, and anything that's above or below is essentially the average. Okay, so that's a line of best fit. Now, let's say, for example, instead, my data looked a little bit like this. Okay, here, my line of best fit might actually be more of a curve. All right, and again, it's not connecting the dots, but it's a smooth line. And of course, you need to have a title. Okay, so those are rules I want you to follow for page 13 of your workbook. Now I want to talk specifically about distance time graphs. Now, if you notice here, so distance is on the y-axis, my unit is meters. Time is on the x-axis, my unit is seconds, and I have a title. Okay, now these are just sketches, they don't actually have numbers, but both of these graphs are showing uniform motion. So if I were to describe this motion, I would say the object is traveling at a constant, steady speed. All right. Now, the slope or the steepness of that line helps us determine how fast the object is moving. So if you take a look at these three options, the steepest line is the one that's traveling the fastest. Because let's just say we put some imaginary numbers in here. 15, 20. Okay. So the line that's traveling the fastest, again, we have distance over time, is traveling about 20 meters. Let's say this is 4 seconds. The slowest one is traveling about 5 meters in 6 seconds. All right, so the speed is clearly faster with this, more steep slope. So just by analyzing the data here and looking at the graph without doing any calculations, you should be able to see which line is showing a faster object. Okay, we have distance over time. Now, when we're graphing distance over time, well, actually, I'll get to that in a minute. Okay, so general rules are the steeper that slope is, means the object is traveling more distance in less time, therefore it's traveling faster. That straight kind of diagonal, I shouldn't just say straight, a straight diagonal line on a distance time graph is showing you that speed is uniform. So by straight diagonal, I mean this, okay? A curved line on a distance time graph actually indicates that speed is changing and it is non-uniform and it's showing acceleration. So that would look like that. Okay, so you are going to be asked to kind of describe motion after looking at graphs. So this one would show acceleration and this one would show constant speed. Okay. Now, it's important to know that when we're talking about distance time graphs, think back to the difference between distance and displacement. Even if a person were to turn around and move the opposite direction, distance still is about adding that value up. So distance time graphs can only ever increase and that line can never go backwards. So what I mean by that is, let's say, okay, a person was traveling 5 meters forwards and 5 meters backwards and 10 meters forwards. That line is still only ever going to increase, okay? Because distance is not a vector and distance always has to be positive. Later when we move on, you'll learn that there are position time graphs or displacement time graphs where the line might go up and down, but that cannot happen with distance. Okay. All right, that leads us into a bit of some calculations on determining the slope of a line. Now, you may have covered this in science or math before, but calculating the slope of a graph is essentially about comparing a ratio between rise and run. Okay, where rise is referring to the y-axis. So if this was my line here, my rise would be the length on the y-axis, and my run would be the length on the x-axis. Okay, that is slope. Now to calculate it, you should really choose 2 points that can be read easily on your graph, and those points should be relatively far apart. So you don't necessarily want to choose 2 side by side. And then it's about a formula, okay, dividing rise by run. So this is the formula here. Okay, slope is equal to rise divided by run, which in this particular case, if I have distance over time, my rise is distance over time. And when I'm kind of doing this on a graph, I choose 2 points. I have to determine the difference between them. So that's where the y2 minus y1 comes in. And I divide them. Okay. Now, if I look at this, if I'm taking distance and I'm dividing it by time, that should look familiar to you from our speed formula. So the slope of a distance time graph is equal to actually calculating the speed of the object. Okay, so let's do an example. If this is my graph, and it is asking me to find the speed of the object. Well, I have a distance time graph. To calculate speed, I know that I can calculate slope. So slope is equal to, and instead of just writing rise over run, I'm going to write it as y2 minus y1 over x2 minus x1. Y referring to y-axis, x referring to x-axis, and 1 and 2 are going to be referring to the points I choose. I always like to actually choose my 0 point. It makes it a little bit easier if I can. And then I'll choose another point, often that's kind of furthest away. So this is going to be point number 1, and this is point number 2. It's very important you don't actually just get to arbitrarily choose point 1 and 2. Point 1 is always going to be the one that's furthest to the left, and point 2 is the one that's further to the right. So if I look at my values here, first I have to plug in y2. So this is y-axis, so it's saying the y-axis value of 0.2, which is 50. And I subtract the y-axis value of 0.1, which is 0. And I divide this by the x-axis value of 0.2, which is 5, minus the x value of 0.1, which is 0. So that becomes 50, and I'm going to actually plug in my units here. Should have been using that. The y-axis is meters. 50 divided by 5 seconds is equal to 10 meters per second. And you'll notice that those units are familiar to speed. Okay, so that's your slope there and how that works on graphs. At this point, I want you to be working on page 13 and page 14 in the workbook, and then we'll be moving on to position time after that. All right, take care.